Hello, welcome back to MAT052. We're going to kind of continue along with this week. And before we looked at confidence intervals, we kind of looked at building confidence intervals, giving some given information. One of the things that you will be concerned with is that you would like to build a confidence interval. And you need to do it to a certain confidence level, margin of error. You know how tight you want this to be, and you're asked to find what would be the sample size that would give you that. So the bigger the sample size, the more accurate you can be in building this confidence interval. It's just so if you can increase your confidence level, like from the 90% to the 95%, and that actually opened up that interval. I kind of spoke about that. But if you have more and more sample size, then you have a more and more better view of what the population data is, and this actually shrinks that confidence interval down, makes it narrower, so you're more precise on what the population parameter would be. So you would like to know, I want to give some margin of error at some confidence level. Tell me what sample size I need to give me that interval and margin of error. That margin of error is that, the plus or minus version of that. Okay. So let's take a look at this. The width of a confidence interval determines how useful the interval is in estimating a population parameter. If I said it's somewhere between 0 and 1,000,000, that's not very helpful. But if I could tell you that the average is between 1,000 and 1,050, that would be very helpful, So we may construct a confidence interval with a given width, margin of error, plus or minus, by choosing an appropriate sample size. We do this by setting the margin of error at a predetermined value and solving the equation for n in the margin of error formula. So here we given E, so we kind of know what the plus and minus is going to be from around the population or the sample statistic to build that interval. And I want to know what size I need to work on. Okay. So we're going to work backwards, and here's going to be some new information. Oh, sorry. I go here. I'm trying to get down to here. So later on, we're going to actually you'll look at this in class, of what I need to do to calculate the margin of error. And there's this thing called Z alpha over 2. That's based on the confidence level. This is the corresponding Z-score that you're going to use to get that particular confidence level. The alpha is the 95. It's kind of the outside of the 95. So if you wanted to be at 95%, the 5% is the alpha, and then you're going to do 0.05 over 2. Calculate the Z-score. But we're going to give you these things right now. And then we're working backwards. So this would be showed up in the equation for E. And then you would do, n is inside, but we're going to solve for n. Use these numbers, we're going to square it, and that's going to give us the sample size we're always going to round up. Okay, so let's kind of look through that. And this is just one for a population mean. And if you know what the standard deviation is, this is kind of odd that you don't know what the population parameter is, but you know what the population standard deviation is. This is kind of one of those where you used to know things have changed, and you just want to know probably the population standard deviation is going to be somewhat the same, but just the population mean has shifted, and this is when you're going to use that. Okay, but again, I'm not doing the margin of error. I'm saying I know what I want to build the margin of error to. Give me the sample size that I need, and this is the formula that you would use for a population mean interval, given that you know what the standard deviation is. Okay. So here's the example. A researcher wants to construct a confidence interval for the mean weight loss for adults on a diet. Assume the population standard deviation is 7 pounds. So this is, no matter what you see, whatever they weigh, this is going to be 7 pounds for a standard deviation, population standard deviation. How many adults must be sampled? How many, the N, must be sampled so that a 95% confidence interval will have a margin of error of 1.5 pounds? This critical value, we're going to work on that in class to figure out how to go about going this way to get this number. But here we're going to give it to you, and you just want to put it into the formula. Okay, so I just start with our formula. The N is equal to, that's what that parameter is, the 1.96. The population standard deviation, they're giving me that already, that's the 7. And I want to do it with a margin of error of 1.5. Okay, this 95% confidence interval and the Z alpha over 2, that is connected. Those things go together hand in hand. Yeah. So let's just see how we plug them into the formula. Again, here's my Z alpha over 2, so that's going to be the 1.96. My standard deviation, there's the 7, so I want to put that in there. I wanted it to be the margin of error of 1.5 pounds. So that's my level of error that I can handle, plus or minus. Put that in there. Do the calculation inside the parentheses. Please excuse my dear Aunt Sally. Do all the stuff in the parentheses first. Multiplication, division, my dear. So do this multiplication, division. I get this number, and then I square it. And I get an 83.66. Now that's a number of samples that I have to have as the people. However, I can't get a sample of a 0.66 person. So what I need to do is sample 84 people. Round up. Even if this was 83.22, still round up. It's a different reason that I'm doing this. I'm not just rounding. I'm rounding up because I can't sample the 0.22, but I need that extra in there. So I err on the side of caution, and then I would go up to 84. Okay. So always round that up when you have a decimal number. Now, if this was just 83, you're okay. 83 people, you can sample 83. You just can't sample 83.1, 83.2, 83.66. You need 84 to build everything out. If you don't get that extra, this is not going to be the right size that you wanted. So that was for the mean. So if I wanted to do so above, I'm building something like, x1 less than the mean, less than x2. And this was going to be the x bar minus e, x bar plus e. Now we're going to talk about, what about this confidence interval for population proportion? Here is the formula that you'll be given this thing. N is equal to p hat, 1 minus p hat, z alpha over 2. It's the very same thing as before. This is related to what confidence level you want to do this interval in, and there's your margin of error. Okay. Now this is asking for a sample. I want to build a sample of size to get this to N, but I need to know what p hat 1 minus p hat is. Sometimes you may have done this from a previous study. If you know a previous proportion from a sample, you could use that as a starting point. If not, we're going to use p hat is equal to 0.5, okay? If there's a known estimate for p hat from a previous study, that should be used. If not, just pick out. This is the very first time we've ever done this proportion study. We're going to start out with p hat is equal to 0.5 in this. Okay, so let's take a look at how we do that. So the minimum sample size necessary to obtain a margin of error E is N is equal to p hat 1 minus p hat z alpha over 2, the critical value, divided by the margin of error desired. Square that, okay? So here, there was a previous year's proportion as an estimate. We use the previous year's proportion as an estimate for p hat. Okay, and p hat was 0.38, 38% from a previous year's study, and now we're going to do another sample to make sure anything's still the same. Okay, and again, what I'm doing is I want my interval to be, x1 less than p less than x2. So my population proportion is in there between a minus and plus and minus e that we're given, that 0.05. Okay. So what size sample do I need? Again, I'm going to use a previous year's version, 0.38, and if I didn't have that, this would be 0.5, 1 minus 0.5, which would be a 0.5 again. But here we got 0.38 from the previous year, 1 minus 0.38. My critical value, I'm given this, the 1.645. And again, later in class, we're going to work on these things in class to how to go forward with that from a confidence level. The E, I want a margin of error plus and minus 0.05. Put that in there, and then I'm going to square that. So I do this division, everything inside before I square. Okay, so this was the 32.9. I want to square that. That's my 1082.41. 0.38 again. 1 minus 0.38 is my 0.62, so I've got everything inside the parentheses done. I need to do my parentheses exponents, please excuse, so I got to do that. 32.9 times this, and then I multiply this out, and I get n is equal to 255.02. Now that's pretty close, but if I'm giving it that, we still need to round up to 256. Okay, if this is not 0.0000000, and if I get a decimal place over here, just do one more person. If you can get 255, you can get 256. Okay, so that gives you. So what does that do? If you go and grab a sample of 256, at that confidence level that you need to do, you'll be able to obtain a margin of error plus or minus 0.05. It'll still be in the middle, so you'll have the p hat from that sample, and then you will have p hat plus 0.05, p hat minus 0.05 for whatever this is. So it shifts depending on the p hat, and naturally from sampling theory, this is going to move around a little bit. This will move around, but this should capture at least 95% or whatever the confidence level would be. Okay. So in the previous example, an estimate for p hat was known. That was from some previous study that they said. How about if I didn't have that? Then what I'm going to do is p hat 0.5. Okay. 50% is what I'm talking about, 50%. Okay. So a pollster wants to construct a 95% confidence interval for the proportion of adults who believe that education should receive more funding. What sample size is needed so the confidence interval will have a margin of error of 0.02? And again, later on in class, we're going to start with this, and we're going to come up with that number. That's going to drive what this Z alpha over 2 is, and that's going to determine what the 1.96. So those are kind of matched together for Z scores. Okay? But here's my margin of error, E is equal to 0.02. Okay? But I have no previous. So remember I had that N was equal to P hat 1 minus P hat Z alpha over 2 E squared, like that. The P hat we're going to use is 0.5. So 0.5 times 0.5 is going to give us the 0.25. Again, the Z alpha over 2, 1.96.02. That's the 98, and we're going to square them. Gives us 9,604 times the 0.25, and that'll give us N is equal to 2,401. Okay, and no need to round up. Okay, so that's what I need to give E 0.02 at, and again, let's go back up. That was at 95% confidence. At 95% confidence. Okay. So I hope you found that informative enough that you can go through and pick up these things. Everything should be the very same thing. Just make sure, what are you talking about? Confidence interval. How many fish must be sampled? Give me the N. And I want to do for the weights of striped bass. So I want to do a mu confidence interval of X bar minus E, X bar plus E. I'm given E, okay, and I want to find the sample size that I want to go out and calculate X bar, okay. And here, this is the key here. Proportion. So I want to do a confidence interval for the proportion. Last year, the proportion was 0.26. P hat is 0.26. Critical value, the margin of error, and then you're going to use that something like P hat 1 minus P hat Z alpha over 2 E squared. Okay, so work on those, do the best you can, and turn them in. We'll see you next time.